I assume I'm going to just start now with my PowerPoint. Okay. EnergyPlus, a practitioner's guide. So this is just really kind of like a skin deep discussion of how to use EnergyPlus, what it does, running some basic files, making some modifications, using the kind of GUI interface provided on the PC version of EnergyPlus, understanding how that affects the underlying input files, and how, if you wanted to, you could modify those input files manually, which is something I've done a bit. And then just looking a little bit at the results and kind of understanding the relationship between what we're putting in and what we're getting out. So first of all, what is EnergyPlus? This is directly from the website. EnergyPlus is a whole building energy simulation program that engineers, architects, and researchers use to model both energy consumption for heating, cooling, ventilation, lighting, and plug and process loads, and water use in buildings. I just took the first 4 bullet points of kind of explaining what it does. It computes integrated simultaneous solutions of thermal zone conditions and HVAC system response, which means that if you've got a building and that building's exposed to sunlight and to airflow and maybe there's some infiltration, it's simultaneously looking at all of the external heat transfer that is happening into and out of the building, and it's also looking at how a air conditioner or a heater or heat pump or what have you is going to try to keep up and keep to whatever its design conditions are. And that could be just a set point or a dead band, trying to keep the temperature between 68 and 72. It can model humidity sensors. So you could, in theory, have an air conditioning system that's trying to keep both the temperature and the humidity within certain ranges, and it will model how that system responds mechanically to all of these things happening on the outside of the building, as well as internal loads. If you've got people in the building, we produce both sensible and latent heat. Does anybody know the difference between sensible heat and latent heat? You didn't cover this in thermal? It's super disappointing. Okay, so sensible heat is heat the way that we think about it. So if you've got air and it's warmer, it's at a higher temperature, that's more sensible heat. Latent heat is very interesting. Latent heat is when there is more humidity in the air. While it isn't actually heat, or it's not actually heat the way that we think about it, there is an energy content to having water in vapor form. And if you want to decrease the humidity of the air, it actually takes a significant amount of energy to suck that water out and condense it on some sort of coil. When we're engineering air conditioning systems for buildings, we're always working around both. If you've got a building with a lot of occupants, there's a lot of moisture being put into the air. As humans, we produce about as much latent heat as we produce sensible heat. And you're always trying to take out both the sensible and the latent if you're air conditioning. If you've ever been in a really crowded room that was cool but very damp, what's probably happening is that the air conditioning system is successfully cooling the air but not removing enough of the moisture. So you end up with a whole bunch of cool air that's also very wet. And that's how you get condensation on windows and the like. So yeah, it models all of that. It also will model interactions between different elements in a room. This is the heat balance-based solution. So in addition to just kind of thinking about the room as a single box with heat coming in and heat going out, it will also look at the elements, individual elements within the room, and how, if you've got one wall that's warm because it's exposed to the sun, that will radiate heat with the other walls and with the other surfaces of the room. It does this incrementally in time steps. So typically, you'll do a 15-minute time step where it'll assume all the conditions are constant for 15 minutes. It will solve that steady state heat transfer problem, or that non-steady state heat transfer problem. It will kind of update all the temperatures as everything's changed a little bit, and then it will run the next time step. And lastly, because air conditioning, you're typically moving air into and out of the space, we're also doing fluid mechanics calculations. And then kind of the thermodynamics of having all these different things mixing. So you're pumping cold air into the room. It's probably got a higher relative humidity because it's colder and it was just cooled by a coil, lower overall moisture content. That's mixing with the air in the room, which is going to be warmer. And then you get some kind of adiabatic mixing calc. That air from the room is now being exhausted out or being recirculated. So it's simultaneously doing this mass transfer model while it's doing heat transfer. So I hope that all isn't overwhelming. The kind of takeaway, though, is that it's just a whole bunch of math. I mean, it's the kind of stuff where if you wanted to do even a very, very, very simple version of this for one time step, for one steady state condition in a spreadsheet or by hand, it would take hours and hours and hours and hours. And EnergyPlus is capable of doing this for an entire year pretty quickly. So it has a lot of power, but with great power comes a great need to pay very close attention to the details, because it's very easy to put in something that's totally wrong and either crash the model or get totally absurd outcomes. And you always kind of need to be vetting what you're putting in, what you're getting out. So I think I already discussed this a little bit. I just want to, I won't spend any time on this. I was going to draw for you all of the heat transfer in and out of the building, but I think we discussed it enough. But yeah, I mean, if you have your box, there's an awful lot that can go on when you're thinking about even just a single room where there's a floor interacting with the soil, there's a roof, there's different walls, they all have different solar exposure. It can get complicated. Any questions so far? Okay. Very broadly, there are 2 input files that you're putting in at any given time. There is the IDF file, .idf, and that is a description of the building's geometry, materials, temperature set points, all of the HVAC systems, and how they're connected, and what your airflows and fans, and all of the details of what you're putting in. There are instructions for how to run the model, and depending on the physics of the building, you may say, well, an hourly time resolution is adequate, or if you've got a building with much faster transients, you might want to go to something like a 5-minute time step. And I'm sure people will take that even further and try to do sub-minute time steps. I think EnergyPlus is flexible enough that if you were really determined to go to a very high resolution, you could. And then also sometimes sizing instructions. A lot of the time, when you're designing an air conditioning system or heating system for a building, the biggest thing that you don't know, and one of your biggest jobs as an HVAC engineer at the beginning, is how big my equipment actually needs to be. So the architect sends you the designs for a building, you have a rough sense of what the U values of materials are going to be. And really the first question you would have to ask is, do I tell this architect to buy the 4-ton unit or the 5-ton unit? That's just a measure of BTUs. So do I get the 50,000 BTU unit or the 60,000 BTU unit? So if you don't know that, you can't necessarily prescribe it for EnergyPlus going in. So you can also tell it, I don't know how big the equipment is, you figure it out for me, and then run a simulation of how much energy we're going to be using. So that's the IDF file. The other file is the weather file. And there are weather files for everywhere, several at least per state everywhere in the country. So anywhere that you're putting a building, you can normally find a weather station close enough to get a good weather file to run your simulations. The interesting thing about these weather files is the EPW weather files that we use for EnergyPlus. they're actually more detailed than most generic weather station data. So if you download weather station data from the National Oceanic and Atmospheric Administration, you'll get a lot of information, but you won't get things like solar beam intensity or diffuse solar intensity. And you almost certainly will not get things like solar angles. Now, if you've taken Professor Modi's class, you know that we can calculate all that stuff. But the nice thing about EnergyPlus is that, or these EPW files, is it already has everything in the file. So the reason I point this out is that if you're trying to bring in a weather file, or trying to make your own weather file to plug into EnergyPlus, and you want to just take something off of, say, the ISD system, which some of you might know about, then there's actually some serious steps to making that file work with EnergyPlus. Hassan has a question.
Yeah, so what year are you using for weather file? Is it like the most recent year that we use for this, or is it like the worst? Because you're designing for, are you designing for the extremes?
Okay, so that's a very good question. So there's really actually, there's two files you put in here, but there's really a third file. And so let me just say, so the weather file that we use for simulations when we're interested in what is the energy usage of this building going to be over the course of a year, we use what's called a TMY weather file. That's a typical meteorological year. And typical meteorological year files are not updated very frequently. And the idea is to have the most normal year you could compose. It's a composite of years throughout history. And the way they do that is they'll take January of 1980, and then February of 2005, and then March of 1996. And they'll make this composite year with your most normal January, your most normal February, your most normal March. That's not your extremes. Now, when you are doing your sizing, you use what's called a DDY file, and we'll look at this a little bit later, and that's your design day. The design day is your worst case condition. So you design for your worst case, and then you do your simulations with very, very average data. And an error that we see a lot in the literature from people who are modeling buildings but haven't ever designed buildings is they don't realize that if you're only sizing things for your typical meteorological year, then everything's going to be undersized. Because by very definition, the EPW does not have the warmest July. It has the most average July. And we, of course, want to be sizing all of our equipment for the warmest July. So that's a good question. We'll look a little bit at these DDYs later to see, first of all, how do you come up with a design day and understand kind of what those extremes are going to be, and then how do you plug that into EnergyPlus. Any other questions?
About that typical meteorological year, so you said that like typical like January in 1968 and February in 2006 or something like that, but yeah. Doesn't, like, for example, like average temperature change like by decades or like by several years?
Yeah, that's another problem. And there is ongoing scholarship about how do we update these files, because we aren't designing buildings for 1980, we're designing buildings for 2040. And 2040 is going to have a fundamentally different climate than 2080, you know, not just because of error and not every year is exactly the same, but because of climate change. So there's been scholarship I've seen at least for the last 5 years about if we're to use projections of what the future climate is going to look like, how would that impact and influence the design of buildings and the energy kind of implications. And, you know, the results there are interesting, normally pretty subtle. I think the biggest outcome I've seen is in a lot of climates where we're expecting more warmer weather. It means that we're going to have to be designing buildings with more air conditioning, and we're going to be expecting significantly more air conditioning energy. between now and then. And as a building systems engineer, if you're designing HVAC, all you can do is design bigger, more robust air conditioning systems, which might future-proof your building for climate change, but it's definitely not going to do anything to ameliorate climate change. So you know, you're kind of just in the position of responding, but you know, it's a tough situation, because even if you really care about climate change enough to think about it in your work, you're only going to be making things worse by designing bigger heating and cooling systems. Any other questions? Okay, so those are your input files. You get a whole bunch of different output files, and these are just a subset. And the confusing thing is they all have the same name, and it's only the suffixes that are different. And you can specify more and more and more output files. So the first one, the one that's most important to look at right away, is your .air file. And that will tell you if there were problems running the simulation. If you're making your own files, you probably won't run any serious errors today. But when you're actually building your own stuff, most of the time that you run a simulation, you're going to get some errors, and maybe really severe ones and maybe kind of minor ones. But it's important to look at that first. You get this EIO file, which is basically a summary of all the steps that EnergyPlus took to solve your model. A lot of it just looks like a repeat of what you plugged into your IDF, but it kind of confirms that EnergyPlus read the file the way that you intended for EnergyPlus to read the file. And then lastly, there's the DXF file, which is a 3D wireframe with the geometry. So if you have a Premiere drawing program like AutoCAD that can actually look at 3D wireframes, then you can make sure that the geometry you described is accurate. One of the biggest problems with EnergyPlus, or at least the basic version of EnergyPlus, is the way that you describe the geometry is just positively archaic. You have to literally define every single point. So it would be like, if I want to describe these 4 walls, I actually have to say, okay, wall number 1 has, you know, a point here and a point here and a point here and a point here. And then wall number 2 has a point here and a point here and a point here and a point here. And if I want to move this wall, I have to change all 4 of these points by changing the X direction. And then I have to change these 2 points on wall 1, and I have to change these points on wall 3, and on the ceiling and on the floor. So it's just wildly difficult to describe geometries using the basic version of EnergyPlus. But there are all kinds of other tools used to help you generate that. So we'll get to that a little bit later. Any more questions so far? Don't hesitate to ask. There's so much here, and it is very confusing the first time you see it. Okay, so let's move over to looking at our EP launch. And I started to say before, in case everybody wasn't here, we're going to be looking at the getting started document, starting at the end of page 35. There are a couple different example files that we can make, so we can run some just very basic simulations with a very simple box building. So find that document, get to page 35. We're starting with exercise 1A, which if you browse in EP launch, it's EnergyPlus example files, basics files, and then 1A. And you probably don't have these other ones yet. I think these are all ones that I made. But yeah, start with 1A, and then we're going to make our 1B, 1C, 1D. And once your EG launch application looks like this, why don't you all give me a thumbs up in the in Zoom.
No, I'm just having one problem where even though I downloaded it, like I don't have any files like you, like the folders, should I say, that includes those examples, but I only have like HTML that says example file summary.
So if you go into your EnergyPlus
Yes,
installation,
there are no such thing as like those DLL files, or neither those like 10 different folders. It only has like 4 HTMLs with different like shortcuts to the program.
okay. Do you have EP launch though?
Yes, I launched that.
Okay, but you don't have the example files. I don't want to stop what I'm doing. Hassan, would you do me a favor and email Daniel the example files folder?
I'll type
Sure.
my emails.
I'll do that.
Okay, thanks. So you guys, I'll keep talking a little bit about IDF editor
Thank you.
while you guys are all getting up to date. So I don't know if you saw, I opened IDF editor here. The IDF editor is only for PC. There's also the text editor, which we'll look at a little bit later, that lets you manually modify these IDFs in the Mac or anywhere. And it's surprisingly useful once you get some familiarity with the software. So we open up IDF editor, and IDF editor lets us edit these IDF files, which are ultimately just text files, but it can be a little bit confusing the first time you see the text. And IDF editor has all these options for simulation parameters, and you can see there are a lot of them. And this being a very simple building, most of these are blank, so it's just ... We don't have any baseboards, we don't have any air terminals. We have this ultra simplified building. So everybody who has this loaded right now, if you guys want, you can also open IDF editor and scroll through this with me. We do have construction. So these constructions tell us, maximize this. These constructions tell us we've got a description of a wall, and we can see the layers of the wall. There's wood siding, fiberglass insulation, plasterboard. We've got a description of a floor, and we've got a description of a roof. And then we use those constructions. This example file uses those constructions to actually build the geometry. Now, if you go to View, Show Classes with Objects Only, or you just press Control-L, it will take away everything in the class list that isn't already being used in this IDF. And now we have this much, much reduced version of the IDF. We just looked at those constructions. Incidentally, the constructions are built on materials. So, this wood siding here is being plugged into the construction, the description of the wall construction, but it also has to be defined as a material. So, you see plasterboard, and you actually put in all of the thermal properties that we cover in heat transfer. So, and then some. So there's roughness, which influences how the material is affected by convection, the thickness, the thermal conductivity, the density, the specific heat, thermal absorptance, solar absorptance, visible absorptance. This all has to do, these are radiative properties. So you got basically your conductive properties here, convective roughness, and then your radiative properties down here. So yeah, there's this whole process. If you want to build it from the ground up, you got to define your materials, use your materials to define your constructions, and then you use the constructions to describe the building surfaces. So we've got a north wall, we've got east wall, and I think I can go to view wide column. You can also manually drag these if you can't see it all. So there's a north surface, there's a south surface, west, a floor, and a roof. And each of these is has a construction name. So we apply the wall construction, which was defined to all the walls, and the floor construction to the floor, and the roof construction to the roof. And then this is what I was saying before. This is the really difficult thing, where you have to manually define all your vertexes for your geometry. So, you know, your vertex 1 for the surface north coordinate, you have to define the XYZ points for the vertex 1, XYZ points for vertex 2, XYZ points for vertex 3, and for 4. So it's exactly as painstaking as you imagine it is if you ever need to slightly change the size of something or move a wall or anything else. There's some other stuff active in here. We have a very basic HVAC system. It's called the ideal air load system. And this is a really simplified system where we're not actually modeling air going over coils. We're not modeling air going into the room and mixing it. We're not modeling ducts or anything. We just assume that there's this perfect system in the room that can do all of the heating and cooling that you need to do. It will give you the output of to keep the room within the set points in this hour. This is how much cooling you needed to do, and this is how much electrical energy it took. When you get to more complicated buildings, you actually define a real HVAC system, which is much more complicated. And again, all these things, I don't want to intimidate you too much because it's very rare that you ever have to build a building entirely from the ground up. This ideal loads air system is very useful if you're just trying to get a rough estimate of the energy required to heat or cool a building over a year, and if you're trying to figure out what your peaks are. So how many BTUs per hour the air conditioning system you install needs. If you then are designing a very specific system that's going to have some constraints and may or may not be able to do all of the transients that you want it to do, that's when you're designing a full system and actually simulating it in EnergyPlus. Okay, any questions now? Are windows included in this example building? No, but you're going to add them. That's example 1B. So you're going to add 2 surfaces, 2 windows, 4 vertexes each, and it's going to be a pain in the butt. And then you can imagine what it's like to put a whole multi-zone building together. Any other questions?
I have one question. Have you ever used the Mac version doesn't have a graphical interface, is that correct?
Yeah.
Have you ever used that version?
Yeah. In fact, before we can look at that a little bit, and I'll show you what it looks like just to look at the text files. But when you're just starting out, it's really nice to have IDF editor because it tells you how to build stuff. But let's say, so we looked at material, we looked at construction, and we looked at ideal loads air system. So this is all in the IDF editor. I'm going to close out of this, and we're going to open it in the text editor. And if you're working on Mac, the text editor looks exactly the same. So on the Mac side of my computer, I can open any IDF as a in text edit or in Sublime or in any other text editor, and it will look roughly like this. If I search within here for construction, yeah, these are defined in the same way. But I don't know exactly how important all the spacing is, but you basically would be giving it the same information, but manually typing out, this is a wall and these are the layers of the wall. This is the floor and this is what the floor is made out of. This is the construction of the roof. If we look for material, oh, that's funny. Huh. Oh, you know why? Because it's yeah. If we want to look at materials, all the materials are defined here in text edit. So there's nothing stopping you from using this interface and manually saying, I want to add a slightly different plasterboard that's got, a smoother surface roughness, but without the drop-down menus and without kind of having IDF editor as a template. If you're not super familiar with all of this information, you wouldn't really know what to put. Any other questions? Okay, so that's IDF editor for now. That's just kind of a basic view of IDF editor. Again, it's the exact same files, whether you open it in IDF editor or just as a text file, but it's, while you're just starting out, IDF editor is quite nice to have. So we've got it loaded. I have no weather file selected, but the IDF already, and I meant to show you this before, has the design simulation controls, sizing period, design day. So the IDF already includes your design day information. How they do these design days is pretty interesting. So basically, as I was saying earlier, the design day just tells you the extreme conditions. It's not the same as the typical meteorological year data. It's what's your absolute worst case hot condition, summer design day, what's your absolute worst case cold condition, winter design day. We're using Chicago, the 0.4% worst summer design day, and what is the 99.6%, so the same statistic. In the other direction, worse winter design day. The interesting thing is you don't, for a design day, give it a full hourly load profile. What you give it is a maximum dry bulb temperature. So what's the warmest it's gonna be? And then what is the daily temperature range? Can someone point out what's interesting looking between the summer design day and the winter design day? What kind of stands out between these two? Other than the temperature is different. So the big difference is with the summer design day, you're still modeling a temperature range. So even when they're modeling the summer, you don't assume that it's going to be 32.8 degrees Celsius and full sun for 24 hours. You're still modeling that there's this transient that the air conditioning has to keep up as it warms up and cools back down. With the winter design day, they don't measure any temperature range. So with the winter design day, you're just pretending that it's minus 21 degrees for the full 24 hours. So when the outdoor temperature isn't changing and you're modeling how any kind of thermal system responds to that, what kind of problem is it? This is a question for Daniel, since he was in that class. Daniel, are you still there?
Yes. Could you repeat the question again, please?
So when the outdoor temperature isn't changing at all, the outdoor temperature is totally constant. See, there's no range. So it's this constant minus 21 for the full simulation. Mm-hmm. What kind of problem is that?
Steady state?
Yeah, it's steady
state.
It's
just I was overthinking it. Okay.
Yeah, it's okay. It's okay. Hassan was the course assistant for heat transfer a couple of years ago, so he's got an edge. He's too much of a pro. So for winter design days, the way that EnergyPlus and kind of the whole field operates is you do what's called a steady state heat loss problem. So you just say minus 21 constantly. What kind of heating system do we need to keep up with just that steady state, frigid cold temperature continuously? With the summer design day, your simulation, the kind of standard is to still solve a transient problem where it is heating up and then it cools back down, and you just need to keep up with that cycle. This is a great opportunity to look at the engineering reference document. This, incidentally, so the engineering reference document, if you have the documentation, it's about 1,000 pages, and it's probably the best HVAC textbook you can find. It describes everything kind of in the context of EnergyPlus, but it also just tells you everything you need to know about how to model energy in buildings, whether you're using EnergyPlus or a spreadsheet really just how the whole field thinks about these problems. So this section is 5.1.1, Energy Plus design day temperature calculations, and it kind of runs down how it takes the maximum temperature and the range and creates this daily load profile. And if the range is 0, the daily load profile looks constant, 0, or it's just 1 constantly. It's always just that, that minimum. But if you have a range and a max, it will create this 24-hour profile. And that is what EnergyPlus will simulate to do the sizing for the building. And yeah, I mean, this is great. So it, you know, it shows you how it creates these design days. It can tell you how its sky radiation model works, and it will give you a bunch of citations of all the different models that are used. And you keep scrolling, and you know, sky temperature calculations. There's a lot of really good stuff in here. Okay, so I'm going to go back to Windows. Okay, I think we have gotten a good look at this exercise 1A example. I'm going to close that. Okay, so now I feel like I built it up enough. We can run it, and it's just going to dump all of your outputs in the same folder. So it's a little messy, but that's okay. And hopefully you guys all have this cool terminal pop-up where it shows everything that it's doing. I think this disappears as soon as it's done. But yeah, so you get to see that it's running through this whole thing. Took about 25 seconds for me. Has everybody else raise your, give me a thumbs up if you successfully were able to run the whole thing and you're getting 0 warnings, 0 errors. Yimbo, Ali, have you guys had any success or any problems? Yimbo, okay, good. Ali, are you having any trouble with it? Okay, I'm going to keep going. So if you go into, oh, he's just listening. If you go into example files, and then basics files, you'll have all your outputs. So there are, yeah, these are all mine from that I ran just now. So the error file, always the good thing to look at first, and you can see that everything looks like it ran pretty well. Often not the case. There's the EIO file, which basically just tells you what EnergyPlus did. It's not that interesting, but it did this ground temperature calculation. You know, it did this zone air, it looked at carbon dioxide. It actually did even more than you think it might. Here's a summary of the materials as it understands them, which is basically just a repeat of what you told it, but it's good to know that it understood what we put in. So this can be useful for troubleshooting. If you're getting something really bizarre, you can go in and kind of figure out. I haven't needed to, but. Oh. Sorry, my earpiece disconnected. Okay, so that's your EIO. There's also a DXF file. Unfortunately, my license for AutoCAD has expired. But if you open the DXF file in something other than AutoCAD, it just looks like a rectangle because it's the plan view of the building. But if you have AutoCAD and you can put it into a 3D isometric view, you can actually see the full box. And you can see how all the walls connect. And if the walls aren't connecting, and I have had problems where the walls didn't connect correctly, then you can kind of troubleshoot that using the AutoCAD. And I think there are also ways using EP launch to just do the geometry modeling, check that it was correct before trying to run a whole annual simulation. And then the last thing is the CSV file. This is the most interesting. This is really your output. And it's kind of defined. You can tell EnergyPlus what you want output in your CSVs. In this kind of default version, you get just the basic stuff, which is, so remember, we didn't use a whole annual weather file for this one. We just did the design days. So it gives us July 21st, and it gives us this 24 hours of July 21st. And then it also does January 21st, does 24 hours of January 21st. And you can see, as we were talking about earlier with the design day, for August 21st, it does create this 24-hour sinusoidal profile where in the middle of the night, it's 23 Celsius. By dawn, it's cooled down to about 21 Celsius. It heats back up to 33 Celsius and then cools back off. So it's exactly that kind of swish that we were looking at in the engineering reference. Conversely, for the winter design day, January 21st, it just said temperature's constant, -21 all day. Nothing's changing, no solar. And you can see that the rest of the inputs reflect that. It's all a steady state simulation. So looking at our summer design, it starts out at 23. There's no heating energy. And there's also actually no cooling energy in the first couple hours. So it's 23 outside, but it's 22 inside, and this building's well insulated enough that we're not losing too much heat to the outside. So the air, the cooling system doesn't have to keep up doesn't have to do any work to keep up and keep the air temperature within the bounds. But you can see that it's, 21, it actually falls a little bit, but this is very little change, a fraction of a degree. It's starting to warm up here in the morning as the sun hits the building, and it heats up to 23.98. And then as soon as it hits 24, that is the upper bound for this particular building's, it's called the dead band, how hot or cold it can get in the room. And that is when your cooling system kicks in and it starts doing a bunch of cooling to keep up with it. And I'm just seeing a question. If the walls don't connect, you just get thrown in air. Yeah, it's not smart enough to read that as a gap. If you want to put a gap into a building, you have to you have to put a gap in. You have to define it as, and there's so many weird hackneyed things. So you have to, I don't even know if you can describe it as a gap, or you have to describe it as a duct with a set airflow, or an airflow that's responsive to pressure differences. It's people have made all kinds of weird modifications to simulate things like infiltration just through an orifice. Good question though. Yeah, but yeah, if the walls don't connect, you just get an error. So yeah, the wall room temperature gets up to 24, and now your air conditioning system kicks in. And then once the temperature drops back down to 23, and this is going to be at 8 p.m. So it's got back down to 23 or just below 24. The sun has set, so you don't have those strong solar gains anymore. And even though it's a little bit warmer outside, the building is starting to cool off. There are probably, there are different reasons for that, but there's a lot going on. So it could be that once the sun sets, even if the air temperature is still warm, it's radiating heat off into the atmosphere. And as Daniel knows, we did a problem on this, that sometimes that radiative loss can exceed what your convective gains would be from air. I assume that's what's happening here. So the temperature inside, without any help from the air conditioning, is continuing to drop, even if the outdoor air temperature is a little bit warmer. So this is just one day, and it did a lot of math here. You can imagine for a full year simulation what it's doing. The winter design day, much less interesting. So it is trying to keep it at a minimum temperature of 20 degrees Celsius inside. That's your lower drift point for the deadband. And it's just pumping out constant number of joules to make up the difference for the steady state heat loss through the building. Whew. Okay, any more questions?
How does it model the thermal occupancy and the activities the occupants are doing and stuff like that?
Yeah, I think that's example 1C, add internal loads. So if you guys have your getting started document, we just did 1A together. So for example 1B, you are going to be asked to create a duplicate of 1A, change the name to 1B, and then there's this kind of manual process for creating a window construction. You got to bring the materials in, create the window construction, define the vertices of the window, and then apply the construction, and that's how you add a window. So I think what I'd like to do is give you guys all 5 to 8 minutes to just try to follow through exercise 1B. That's section 4.2.2 on page 37, or it should be on page 37 of getting started. I realize that since I have a slightly older version of the documentation, that could be plus or minus a page or two, but it should be essentially the same instructions. So why don't you guys all take a few minutes to just kind of at your own pace, try exercise 1B. And with the caveat that they tell you to center the window, and you don't have to do, as long as the window is actually in the same plane as the wall, it can be any size, and that's fine. I want to cut you guys some slack. But I'm going to hang out. I think I'll be doing it too simultaneously. I just want to give you guys an opportunity to do it yourselves as well, and you don't have to be looking at my screen share. So yeah, get going on that. Let me know if you have any questions. I'll be doing it too. And then we can look at how adding windows affects our roads. So incidentally, these data sets are also just IDF files. So it's a data set, but it's just another IDF file. And the only thing that it has is just a big chunk of definitions of different kinds of windows for this one. Or if you look at different data sets, it's just got, it's an IDF with just a ton of definitions of schedules, a ton of definitions of fluid properties or electric generators or cooling coils, chillers, boilers, what have you. And I don't know if I said before, but if you guys want, you can just put in one window. Don't feel that you have to put in two, because it's just the same thing twice.
Noah, how did you collapse your class list on the left?
You can press Control L, or you can go View, Show Classes with Objects Only.
Okay.
Illustrations. And here's another thing. So you have to define the surface that the window is part of, and then you also have to match the vertexes or the vertices, and it doesn't help you at all. So while you're adding this, you have to be double checking that your vertices actually are coplanar with the surface that you've defined. It would be very nice if it helped you select them, but it does not. There's also a multiplier, which is cool. So it's a little bit of a cheat, because you're not actually defining all of the, if you've got 6 windows on a wall, they're all going to be in slightly different locations, and you're not actually defining all those locations, but you can just define one location and then say, and also there are 6 of them, and it will do the math. Oh, and then the last thing, I think it points this out, is the vertices have to be defined clockwise if you're facing in from the outside. These are all going to be x equals 0. So you're working in the YZ plane, but then you have to be working kind of clockwise in the YZ plane. So I did mine x equals 0, 5 over on the y, up 1. Then I moved up to 5, 3. Then I moved over to 2, 3. And then I moved down to 2, 1. And that should make a rectangular window that's facing out. So when you go back to EP launch, make sure you're actually selected 1B. It should still have 1A selected as a default. Are you guys ahead of me? Have you already done everything, or are you basically moving at the same speed? Ooh, we got a warning. If I go to my error file, base surface does not surround subsurface. Overlap status, there's no overlap. The base surface one time. Oh, you know why? Because I forgot, I confused east and west. So that's exactly the thing you want to avoid. I applied it to the east window, but I was using the west geometry. I was using, I don't know if you guys have this picture, but I was using x equals 0. So I need to go back into my IDF editor. I didn't even mean to create an error, but I did. Oh dear, I've got 3 instances of IDF editor open. So I'm going to go back to my output. Yeah. So I applied it to the east. I meant to apply it to the west. This is a west facing window. I'm going to save it. Those. Okay, let's try that again. Oh, I still have a severe error. You have to learn to not take these personally. Ooh, and this was a fatal error. Maybe I had it backwards. Maybe they're not. It might be a counterclockwise. It might not be counterclockwise. It might be counterclockwise, not clockwise. It could be a right-hand rule thing. So I have it applied to the west surface. I think I must have defined my vertices backwards. Are the rest of you, have I caused you all to get the same error that I gave myself? You got, yeah.
Defining the east window, so
Okay. Yeah.
way behind you.
Okay. So this is a west. You only need to do one window. So I'm defining a west window, and
Originally did an east window, and I'm on the trying to define the vertex. I'm very confused. Should I just follow you with the west window?
yeah, but I think I did it backwards. I was defining clockwise, and it might actually be counterclockwise.
Counterclockwise, okay.
And instead of redefining all the vertices, I'm going to move it back. I'm going to make it an east window.
I get what you're saying, okay.
And I'm going to move all of my x coordinates to 8. So now it is a correctly defined west window, or will be. I think it must be a right hand rule. So you're defining it counterclockwise, and then your window's facing outward.
And here you just like what you said, just change the direction only, right? Of how you defined it.
Yeah, if you did it backwards and your window is on, say, the west side and it's facing in, you'd have to kind of go back and define all of the vertices backwards. I was not downplaying how annoying it is manually defining the geometries in EnergyPlus, or I wasn't exaggerating. Okay, so I didn't want to go back and redo all the geometry, all the vertices, so I just made mine an east window. It should now be facing out, and I changed all the x coordinates. I think I can leave that outside condition blank. Yeah. Okay, so I'm going to save it. Let's see if now it runs. Okay, now it ran well. I've got one warning, but no severe errors.
No, just a quick question.
Please.
For this example, we're not using any weather files, correct?
Yeah, we're only using the design day information, and that's already buried in the IDF.
IDF, okay.
Yeah. Uh-oh. I'm still getting errors. Has anybody successfully made a window that actually isn't the same, that actually exists in the wall?
So I'm not seeing a fenestration surface detail class under my classes. Like I see zone, I see building surfaces detailed, and right after that, it's the zone control thermostat. There's no.
So probably because you're only showing the ones that have objects, and if you haven't created the object yet, So hit Control L and you'll get all of them. And then you find that one, add an object. And then when you only show the ones with objects, it'll show again.
Noah,
Yes.
right now I'm like, I don't have any errors, but I only have like one warning.
You say the last thing again? You only have one wording.
Only one warning, no errors, but only one warning.
Okay, what's your warning say?
How can I check like the wording, where the wording is?
If you go to the output files, which should be in the same place as your input files, basics files, there's going to be a 1b.err. That's your error file.
Oh, okay.
Surface geometry.
I got one warnings as well.
I think there should be instructions here. So it's XYZ 8, 5, 1. Eight, 5, 1, 8, 5, 3. This is now defined counterclockwise. 3, 8, 2, 3, 1, and then 8, 2, 1. Good.
Would you want me to read you the warnings that I got?
Yeah, please do.
So it says base surface does not surround subsurface, CHKSBS, overlap status, no overlap.
Yeah. So I think I'm getting the same issue. Let me check. You know what? I might. It's possible is let's look at the building surface detailed and see if these are. So our zone surface. So mine is being applied to the east window. Zone surface east. And yeah. Zone surface east is 8, 0. Oh, you know what it is? Ah, well, I know what mistake I made. I made the windows taller than the walls. So there should be no overlap. Yeah.
How do you know
So I
that?
made the walls are only 2.7 meters, and I think I had the windows extend up to 3 meters. So that's at least part of the problem. 8, 0, 0, 8, 6, 0. Yeah, so let's see if I fix that and I just have it go up to, so it starts at 1, it only goes up to 2, and then it stays at 2. All right, let's see if that does it. You'd think that there'd still be some overlap, but let's try it one more time. Ah, 0 severe errors. Okay, so now I got it to work. How's everybody else doing? So we do want them, it's the right-hand rule. We want to define the vertices counterclockwise, assuming we're looking at the window from the outside of the building, and that way that the surface normal using the right-hand rule is pointing out. And of course, it has to be applied to the correct plane, and it has to be defined in such a way that it's totally coplanar. So if you are still having problems of any kind, then put a please indicate so using your,
No, I
yeah.
think I figured my mistake.
Okay, Daniel got it. Hassan, Yinbo, Jack, how are you guys doing?
Where is it says add output surface list object. How do you do
Okay,
that?
sure.
Yeah, I'm also on the same step.
Yeah, so it's the same kind of thing as it's not going to come up in the class list if an object doesn't already exist. So you need to hit Control L to show all of the classes and then scroll all the way down. Output reporting is the last block of classes. And then you do output surfaces list, and you just need to add an object here and put the type as details.
Okay, I think I found it.
So
Okay, 0 errors.
fantastic. So I guess the output surfaces list is going to be contained in your EIO folder file, your notepad. And I thought we already had this before, but you can see it's got window construction and materials and yeah, unfortunately my version of AutoCAD expired. Otherwise I could actually open the DXF file. And if anybody has AutoCAD installed, you can open the DXF and then put it into an isometric view, and you can actually see the window on the surface. And if you did it right, then they are coplanar. That can be a little bit more informative than just doing it this way. Yeah, there's a surfaces detail for EIO. So in theory, this EIO should have some information on the surfaces. I mean, I see some stuff on the surfaces here, but
If you do just like Control F and shading, it gave me like a few summaries about the shadings.
oh, you did get that. Oh, there. Oh. Yeah. Yeah, so anyway, it gets more interesting. I mean, you can actually, because we're defining all of the geometry, if you have a build, you know, the second floor of the building extends past for the first floor and there's an overhang, that actually gets accounted for. And you could even just manually define overhangs that shade windows, and all of that actually comes out in your energy calc. So it's capable of doing an awful lot. It just is very difficult without using any kind of plugin or interface to define all these geometries. But we'll talk a little bit about workarounds to that. So I'm going to close the EIO for now. And I just want to open our 1B output. And then we can compare and see how the adding the window affected our loads.
So Noah, just a quick question.
Sure.
So like, not the, what is it called? The day, but the night time. So like it's steady state, correct? So if we design this, or like design the IDF correctly, were we able to solve like those heat transfer questions? Like similar to our like handwritten calculation? Yeah.
Yeah, I mean the even this, like, this is like as simple as it gets, because even with before the window, it's just 4 walls.
Mhm.
You're still doing significantly more math here, or EnergyPlus is, than we asked you to do in heat transfer. Probably the simplest example. So the steady state problem I gave you on your final, where
you becoming
yeah,
hermit.
where Noah moves into a ramshackle little mud brick hut in the woods, and then what's going to be the internal temperature. That's basically, you could model that in EnergyPlus.
That is cool.
And instead of having an ideal loads air HVAC system, you would just set the internal gain as 500 watts from the fire.
Fire
and
inside,
then
yes.
Yeah, and it would resolve the internal air temperature for you.
That is
And
so
you might get something somewhat similar. Hi, Professor Modi.
Hello.
So, so we have just modeled, you can see my screen, we've just modeled 2 different buildings, one without any windows and one with 1 window. And now we're looking at how that affects our air conditioning and heating loads. And if you look down at the heating calculation, you can see that adding even the nice double glazed window increased our steady state heating load in the winter design day, January 21st, from 5.8 megajoules per hour to 6.6 megajoules per hour. So roughly 15%.
And that's the heat going into the whole building.
That is the heat going into the building to make up for heat loss through the walls and surfaces.
And roughly how many square foot is this building?
The building is 6 by 8 meters.
6 by 8 meters, and height?
2.7 meters.
6 by 8 meters. So 20 by 25 feet. And about 10 foot high, right?
500 square feet, more or less.
500 square feet. So, and why is it that hourly it remains exactly the same?
You got to go back and watch the YouTube. We're recording this, but there's the standard for doing these design days is you do a steady state calculation for your winter design day, and you do a transient calculation for your summer design day.
Got it. Okay.
Yeah. So that's, you can see very clearly how it changes the output for the winter design day. It's a little bit more. I mean, it's going to be very subtle and interesting. If we actually plotted all this data, because I made this window in mine mine is east facing, you're going to get an earlier peak. And let's see if we can, I'm gonna just plot our winter day. Zone air.
So that's the summer day, right? 721.
Yeah. So this is, so if I,
By the way, did Ali join by any chance?
he was here for a bit. I don't think he was doing the EnergyPlus though.
Mhm.
Okay. So yeah, you can see in our 1B, when I add the east facing window, we have this morning peak because there's a lot of solar radiation blasting in first thing in the morning around 10 a.m. it peaks, which is incidentally the exact time that I have to turn on my air conditioner every morning in the living room. And then as soon as that sun continues to rise and we no longer have the radiation directly on the east face, our load actually drops a little bit.
So EnergyPlus, you specify the orientation of the building.
Yeah, we specify the orientation of all the surfaces, and then it does all of the heat transfer. So yeah, so once it is no longer.
To what extent do you have to worry about neighboring buildings, Noah?
You can put in all of that shading. This is a very simple model. So
Understood, but they allow you to do that.
Yeah.
They allow you.
And when I was doing, so I did a re-facade for 1276 Avenue of Americas. This was about 7 years ago. And that's part of Rockefeller Center. It's one of the Rockefeller Center buildings. The thing about the Rockefeller Center buildings is they're all very big and they're really close together. So if you look at, it can be really significant. If you look at like a Google 3D view of that building in particular, there's a huge amount of shading from adjacent buildings. And it actually affects not just your annual energy, but your peak loads, because there is a big tall building south and west of it, another Rockefeller Center building. So that kind of thing can matter a lot.
Other quick question, or did you show how NREL sort of, does it spit out all these assumptions about a building?
We haven't got into res stock yet.
Okay. No, but just like they do they spit out that on this average building, the orientation is this and all that, or you have to specify it?
You don't specify that. The orientation, I can't remember exactly what assumptions they make about the rotation of the building, but they will define, every window, all of the kind of intricacies of the geometry and how the roof line meets the building and any kind of self shading. All of that is
yeah, but you may decide to place it at a certain orientation yourself.
You might. I have not.
No, I'm just curious what you are doing with your work in upstate.
Yeah, I don't mess around with the building orientations. I use ResStock, the latest version of ResStock. I only make a couple of very minor changes to their underlying distributions. I mostly just take the outputs as they're produced. Anyway, so back to where we were on this. I added the one window, and you see how it affects the air conditioning loads and the heating loads. Heating load is just a 15% steady increase in the steady state for this EPW. With the air conditioning, you see that with the east-facing window, you get this kind of different shape to the load. And if you added a west-facing window, you'd also have it peak more over here. And when people talk about things like passive house design, one of the big staples of designing a passive house building is you don't have any south-facing windows that aren't fully shaded in the summer. Because if I had a south-facing window, I get a big peak right in the middle of the day, and that would normally be a pretty, it's a big peak and it's a lot of energy. So if you have south-facing windows, they have to be fully shaded. And the same thing with west-facing windows. That's the other time where you would typically have a peak. You have to be careful with those. Okay. So as everybody at this point with me, we've successfully run 1B, and we have our CSV outputs. Has anybody had trouble with that?
Can I just ask you one question?
Please.
I think this can be obvious, but right now, like in current stage of our building, is our building on a like a very flat surface with like it's like 360 degrees of horizon?
Yeah, infinite plane, flat surface, no trees, no
Oh.
other buildings.
Okay.
We're in Kansas right now. Any other questions? Okay, so exercise 1C is adding internal loads. I think in the interest of time, since I really prefer to get to the annual simulation, we're just going to skip 1D, or sorry, 1C. We're going to go straight to 1D. And yeah, so go to 1D. We don't need to add the internal load. That's fine. And that way we can practice. Actually, you know what? In the interest of time, you guys don't even have to do this step. I'm just going to quickly run an annual simulation just so we can see what it does and how long it takes. And then I'll talk about some of the other tools we can use, since we only have about 20, 25 minutes left. So I'm not even going to turn off the design day. I'm just going to go to EP launch. Oh, I'm going to add a weather file, and we've been working in Chicago this whole time. So we'll put in our Chicago EPW. As I said before, these are typical meteorological years. And we're going to simulate it as is. So because we're running a full year, wow, it did not take much longer. 0 warnings, 0 severe errors. And the critical difference now is if we open up 1B, we're still going to have the design days, I think, right at the top. And if you are not interested in those design days, you can manually turn that off. The instructions for that are in section 4.2.4. But so we have the design days at the top. Oh no, do I only have the design days? I must have skipped a step. Oh yeah, I have to manually go to simulation control. So if I go to edit, 1B, save as. D. Simulation control right at the top. And one thing is, because we're using this very simple built HVAC system, it doesn't actually need to do any of sizing. It just assumes that your ideal air load system, ideal loads air system can keep up. So it's kind of infinitely large. So they want us to take off the sizing periods. So we're no longer running that January 21st and July 21st, and we are going to be running the weather file. So I save that. We're going to go back to EP launch, browse, 1D, and simulate. Okay. Two warnings. Let's see. No run periods in input. I think I'm trying to rush. Oh, add a run period object to run a full annual simulation. Sorry, I skipped a step. That's what happens when you rush on this. So I'm kind of glad that I'm making these mistakes, because you see how easy they are. And the big thing, if you're going to be using this software, is you have to assume that nothing's going to work the first time. simulation. Oh, add a run period object. There we go, run period. And everything we're just leaving constant. Okay, and yeah, you can see it's using the weather file. So we actually have put something in the IDF that says, yes, we're going to run it with a weather file, and then separately specify the weather file. And there might even be ways to specify the weather file in the IDF. That still was too quick. Trust it. Oh, yeah. So I just manually defined the run period. Try this one more time. Okay. So now it's busting through. It's doing these shading calculations throughout the whole year. And that may have been it. Let's see. So we check 1D air. Okay, all looks good. I'm going to skip the EIO and let's look at the CSV. And I got my fingers crossed. Oh, beautiful. Okay. So yeah, now we have a full annual simulation. So this is no internal loads, but it does have the windows that we added. And raise the top pane. Yeah. And now you can go through and you got, you know, throughout the winter, there's heating. At a certain point in the year, the heating is going to go off and we're going to start, you know, that was all kind of essentially zero.
What
10 to the
heating
negative 8.
systems have you put in now in this?
This is an ideal loads air system, which is basically a kind of an abstracted heating system that can do whatever it needs to do without any constraints. So it's really just a way of computing how many BTUs you need to be putting into the space or taking out of the space without any constraints on how that actually works. So when we get to the summer,
or like the electrical needs of the fan and so on.
yeah, we don't have any of that model. It's essentially the equivalent of just measuring the aggregate heat loss out of the box.
But EnergyPlus is capable of us specifying that, and
yeah,
then it would pull it out.
it's you can go really deep with that. You know, specifying exact ducting. You can end up, you know, calculating air velocities. You can model the coils. You can model the actual condensation on the coils. And, you know, if you've got a system that's slightly undersized for, say, your latent load, it will then be pumping air into the room that's a little bit too moist, and that will create some transients, and it can really, the sky's the limit with the complexity.
Got it.
So anyway, you get to the middle of the summer and you see that there's this very nominal heating demand at some points that wouldn't actually be met, but for the most part, you're doing cooling. When you have simultaneous heating and cooling, it's normally because you've got high dehumidification. So it will cool the air down a little bit more than it needs to suck a little bit of extra moisture out, and then it will reheat the air. And that's actually remarkably common in real world applications. So you sometimes see some heating during the cooling season, but you rarely will see any cooling during the heating season. And here, where it looks like it's cooling, this is really zero. I mean, 1 to the -8th joule is nothing. Okay, so we got annual data. Okay, so I've got 15 minutes, and I just want to talk about a few more topics. I think we're all on the same page that the ways for defining the building geometry is just god awful. And if you were trying to define a real building, it would just be endless to describe the whole geometry using this manual vertex editor. So people, it's entirely, EnergyPlus is entirely open source. So something that exists is called Open Studio. I've got the Mac version open right now. And this is an interface, kind of like the IDF editor, for going in and specifying construction of a building and specifying all the zones. And back in my day, it worked with SketchUp, which was really, really incredible. So you open SketchUp, and anybody who's used SketchUp knows that it's a really fun tool for just building geometries. There was a plugin for SketchUp where you put in this building, you kind of define the zones, or you build the walls and stuff, and then you can actually define the zones and say, this is one zone, this is a separate zone with a separate heating system, and then they connect here, and this is the relationship. You could describe all the shading with SketchUp, so you could do all of your geometry definition in SketchUp. That was kind of the killer app of Open Studio. SketchUp got sold. It's no longer free. Because it was no longer free, the Department of Energy couldn't keep putting money into supporting private software. So now they've got some other kind of geometry interface called Floor Space JS, which I haven't really messed around with much. Same basic principle is that you can build a geometry that actually connects without doing all the manual messiness of defining the vertices, and then plug it in and run it through EnergyPlus. So this is a nice option. I think a lot of people who are trying to do one very accurate model of a building now will use something like Open Studio to describe the geometry. I don't do that. I run lots and lots and lots of really crappy simulations. So there's 2 different ways that I've done that. One is using IDF editor. So we looked earlier at the IDF. This was a residential prototype building. Oh, you can't see my screen. So so the Department of Energy produces these prototype buildings, which are buildings that are more complicated and are typical of the standard kind of 2-code construction for a given year. So you can go down and you can see, these are all of the small offices designed to what's called 90.1, which is the standard, ASHRAE standard. Mike was actually on the 90.1 committee for a number of years. So these are, small offices, mid-rise apartments. They got single family somewhere, all this kind of standard. These are commercial. You've also got residential. So if you download this, you have these IDFs that are already really fleshed out and have kind of detailed heating and cooling systems. If you open up your IDF, it looks like this. It's way more detailed than what we've been dealing with. Now, the nice thing about IDF also being a text file, in addition to something that you can get to through IDF editor, is you can do things like this. I wanted to test out a whole bunch of different furnace capacities. So I made a generic IDF text file. I just wrote in, instead of the capacity, furnace cap, all in capital letters. And then I have an R script.
I have a quick question.
Hold on one sec, I'm gonna finish.
Yeah.
And then I have an R script that loads this text file, individually creates new text files, replacing your furnace cap with whatever the capacity we want it to be, and then can separately run those simulations through a command line. So there's this kind of powerful thing if you're somebody who likes to do coding, where you can, manually go in and, minimum heat pump temp replace these things and run lots and lots and lots of different simulations by manually modifying or writing a piece of code to modify these IDFs. Okay, Vijay?
It is so. That's actually, I think you answered that. This happens in this sort of what looks like command line happens in R or like in EnergyPlus environment.
So EnergyPlus takes this text file
Yeah.
and a weather file, and then it runs the simulation, kind of in a black box. We, this whole time, have been working using something called IDF Editor, which is a nice interface for editing these text files. But at the end of the day, all that gets saved out of IDF Editor, that thing that I was going around and changing controls on, is this text file, this .idf.
I see. So if you want, you can go into this level and change also.
Yeah, so I've got heat pump cap, and I can load this as a text document in R, save, do literally a search and replace heat pump cap with 5 or 500 or 5,000, and then using a command line interface, run that IDF. And that's how I did the ASHRAE paper, where I was running dozens and dozens of EnergyPlus models, all with slightly different parameters.
One more quick question, and I think you address some of the issues of specifying the building geometry.
Yeah.
Is there, I mean, it must get really complicated to specify like loop, like where is the water line running and like how does that?
So some of that's actually, you touched on one of the few things that isn't covered. So if you've got, you can define the zones and the rooms in the building and how they all relate to each other and where there are shared walls, all of that. You can define the HVAC system and the distribution of the HVAC system and which zones and which rooms each pipe connects to. You can define the losses of the pipes, but it's actually very tricky to say this uninsulated duct runs through room number 1 to room 2, and it absorbs.
So the topology, the topology of that network
is defined, but the geometry is loosely defined. Yeah.
Right. Thankfully, is not defined. In fact, what you are saying is that it would have been very hard to define the topology of the routing, and you are saying, in fact, they avoid going there altogether.
Yeah. Okay. And just to show you the complexity of the HVAC systems, so here we do have heat pumps and air conditioners and whatnot, and you can go to a pretty serious level of defining biquadratic functions that determine the efficiency and the capacity of all of this heating and cooling equipment. We haven't gotten to that today.
So it's sort of like, let me just clarify. So let's say there are 4 zones, okay? Mm-hmm. And let's say you had this exact same 500 square feet, but 4 of them stacked one on top of another, and there was a vertical duct going on. As far as EnergyPlus is concerned, all you need to do is say in each of those zones, how much is the capacities and all coming in. You don't need to worry about saying there's actually a common duct going from bottom to top.
Yeah, you don't need to define the geometry of the duct. No. But there can be a lot. So like this building here, which is the prototype building, is much more complicated than anything we could imagine building manually. And you can look, we were struggling, all 5 of us, doing the vertices where, a really simple wall where everything's whole numbers. So you can imagine if you had to manually define, these are the vertices of your walls. And if you want to put windows in the walls, they all have to be coplanar, and all the surface normals have to be in the correct direction. So it gets really, really, really.
So then let me just ask on the water side, suppose like you are routing a water pipe, how does it know, or maybe it doesn't, that water has already given up some heat before it goes to the next room?
So,
and maybe it doesn't.
That's a good question. That's, I remember reading about this online. I think you can define losses, and I think it's tricky to define where losses from a pipe actually end up. And I think people have done workarounds where if they want to have an uninsulated pipe, and they want, they're assuming the losses are going into some room.
That's not
They'll
what
actually-
I meant. That's not what I
Okay.
meant. I meant like it has given up actual heat where needed. So now the temperature is lower entering another zone.
Yeah, so there are ways that people have done, I think, workarounds to get that, where instead of where you'll actually like define a fan coil or something,
Got
in
it,
series.
got it, yeah.
It's all possible, but it gets very complicated.
It
I've
gets
never done
messy.
anything like that. Yeah.
No, understood. Okay. But in
Um,
industry, do you guys do something in-house far more sophisticated than this? Like, do you have your own tools in Arab, like that were much more?
So ironically, most of the tools I used were simpler. Unless you're trying to get lead, you typically don't need to do a full annual energy simulation. You just want
Got
to do a load calculation to determine what your maximum and minimum, your maximum heating, maximum cooling are. So we used a tool made by Train, which is an air conditioning company, to do load calculations. And if somebody was trying to get lead for a building and you actually needed a full EnergyPlus simulation, normally somebody else would actually go and try to build these geometries and run those simulations.
Okay. Hey, I'm going to jump off.
Yeah, I think we're all done now. I mean, I'll hang around for questions, but I think that basically covers everything I wanted to cover. So thanks for joining, BJ, and anybody else who wants to stick around.
No, I thought it is a gory thing, right? But it is, even given where it is, it does do a lot. So that's.
Oh yeah, it does. I mean, Daniel had a final problem that you could have answered in EnergyPlus, and the absolute hardest problem on the final, I think, is the easiest thing you could solve in EnergyPlus. And then it's with EnergyPlus, you can go to outstanding levels of complexity beyond that.
I was just surprised how easy it was to just like use this thing to calculate everything, just for at least like a steady state.
Yeah. So it's much easy. I mean, what I think EnergyPlus, where there's a lot of payoff, and most of the work I've done in EnergyPlus is fooling around with different weather files and like kind of taking the same building into different climates and seeing how that affects things. Those kinds of sensitivities where you're not changing the building geometry and you're just changing the outline physics, that's really rewarding, and you can get a lot of really cool feedback from that. When you're actually messing around with building geometry, it's just a huge amount of, I think gory is the right term. But one thing you can do with EnergyPlus is if I have an accurate model and I say, let's make all these windows better, So I have this model and I've got
one thing
my
I would
fenestration.
love to try, and Daniel, maybe you and Noah, let's follow up later. I'm going to jump off, but if Daniel, you are excited, I want to try something, but I'll come to that later. I'm going to jump off. Yeah.
All right.
Yes, Professor.
Okay, bye.
So one thing that it can be pretty rewarding is if you have a well-defined building and you want to say, let's make all these windows triple pane glass. That's actually a pretty quick update where I go in and I would just, create a new construction. I create a triple pane glass construction, and then I'd update all my windows from, double pane to triple pane, and then you just push it through a new simulation and you get different outcomes. So once you have an accurate geometry, it can be really fun and rewarding to make those updates. But building the geometry is the hardest thing. And that's the reason that people who do this as their day job don't manually do the vertices. They all use something like OpenStudio or some other tool to kind of bring in the geometries. And even then, it's not trivial. The hardest part is doing the geometry. Any other questions? Did everybody basically, or at least we're able to run 1A and 1B?
Yeah.
Yep.
Yes.
So yeah, you guys, I think you're ready. As much of this tutorial, it keeps going. So I think you guys, now that we know you all have working versions of EnergyPlus, if you want to continue on your own time messing around with some of the exercises, you can get pretty nice data. And it all comes out as a CSV, and everybody in this lab has a lot of experience working with that kind of data. So you can do some pretty interesting visualization if you take those CSVs and bring them into R or Python. And and I'll tell you, there are a lot of papers published that are not much more complicated than taking it like a generic EnergyPlus prototype building or something, changing some basic controls, and then kind of comparing the outputs.
Compared to the like Open Studio and Redstock, like as an industry, like which one do they use like more often, or like?
Yeah.
Is that
So
correct question?
So nobody uses ResStock, and I meant to talk about ResStock. I mean, ResStock's still in beta; it's not even open yet. What ResStock is something I'm using now for a current paper. All that ResStock does is generate hundreds of slightly different IDF files and then runs them, and it modifies those IDFs based on actual survey data on how buildings are put together and what kinds of windows and heating systems people have. So ResStock is just one way to punch out a bunch of different IDFs. And it's only really used for research and for market sizing, or it will be. You know, if you have a new heat pump and you want to see how many people will this thing actually help, the idea is ResStock can let you run 1,000 simulations and see what fraction of the buildings actually benefit from your technology. I don't know too much about, I never used EnergyPlus in industry. I think Open Studio is one option. I think people probably use other interfaces to build up the geometry. And if you go into industry and are being asked to do energy modeling in EnergyPlus, they might have Open Studio, or they might have some in-house program. I think one thing is a lot of buildings today are designed in something called Revit. Revit is a 3D modeling tool for buildings that lets you kind of design the building in 3D and then will print out 2D blueprints. I'm sure there are plugins and tools for bringing a Revit model into EnergyPlus. And I actually know somebody who developed one for a tool called Rhinoceros, which is something architects use. It's a little bit less engineering friendly. But I think there are different tools made for kind of connecting the design files for a new building with EnergyPlus. And of course, if you're working on an existing building, all you have is blueprints, so then you're probably better off starting with something like Open Studio, building up the geometry yourself. So there are a lot of options, but I would say that even though you're never going to want to define building geometries here, understanding how to navigate IDFs and kind of know this is all totally essential, however you obtain geometries.
I see what you're saying. Okay, thank you.
Yeah, absolutely. Any other questions? Well, that took exactly 2 hours. This whole thing has been recording on YouTube because somebody sent me an email saying they weren't going to be able to attend, but if you want to go back and look at, review any section of this video, it should all be there. Great. So if nobody has any other questions, I'm going to close out the meeting.
Thank you, Noah.
Thank you.
Thanks, Noah.